Hello everyone. I hope you are preparing for your upcoming prelims examination well. In the continuity of my help for us to revise for the same, I am now taking agent of gradation. Now we have in our NCERT different agents mentioned. In single particular video covering all of them will not be doing justice to it. So today I have selected, apart from our chapter, agent of gradation, the universal agent of gradation, running water. NCERT talks about two things here. Number one, the cycle of erosion, wherein the agent of gradation, how in 3 stages levels out all the variation. And number two, what are the different erosional and depositional features that is developed by river. We want to take these two parts of study today. So let us get going to the details of it. We are dealing with the chapter of our NCERT that reads landform and their evolution. The chapter talks about all the exogenetic forces. Exogenetic forces includes running water, and running water actually applied as overland flow is comprised to be of many constituents. Before we go there, running water is universal agent. We don't want to pick up all the agents together because this topic is slightly bulkier. But if we try to just have a comparison as in which are the other agents that we take into account. I take only one sample case. Supposedly I am taking wind. So where is wind as an effective agent of gradation? Wind is an effective agent of gradation in deserts. So take this as your example. Does it come complete that in deserts I can have running water also? So running water is that exogenetic agent that has got its universal presence. What is the point of our understanding of running water? We want to take that one by one. Please take note of this type of overland flows, and these overland flows are to be identified with certain important terminology that should be there in our information list. So the heading reads type of rainfall excesses, and it includes number one, infiltration excesses of overland flow. It reads, this occurs when the rate of rainfall on the surface exceeds the rate in which the water can infiltrate, and thus this infiltration excess overland flow is one of the example called Hortonian. This is again an important term named after the scholar Robert E. Horton. Now I don't need to remember the name of the scholar from the GS perspective, but yes, what is the reason of overland flow? So one reason is infiltration excess. Second reason as type of rainfall excess is saturation excess overland flow. Now how it is different from infiltration is that when the soil is saturated and the depression storage is filled, the rain continues to fall, the rainfall will immediately produce surface runoff. The level of antecedent soil moisture is a factor affecting the time until soil becomes saturated. This overland flow was referred by R. Dune, and that is the reason we can call it Dune overland flow. As I said, name is not necessarily required, but we need to be aware of overland flow. So overland flow part 1 is infiltration. When the rate at which the water can infiltrate is more than the water that is falling. Second we have learned is saturation excess. Saturation excess is when the soil is saturated with the depression filled up and rainfall continues to fall, and thus there is the overland flow. And there is one third thing mentioned here is subsurface return flow. Interesting one. What is subsurface return flow? Subsurface return flow is when after water infiltrates the soil on an upslope portion of the hill, the water may flow laterally through the soil and exfiltrate, that is flow out of the soil closer to the channel. That is sort of a returning back. That is the water which got percolated in is now coming out. So when I talk about overland flow, you need to understand that overland flow is essentially taken up to be rainfall excess flow. But will I be correct in saying that fluvial action, so writing it here, fluvial action will be synonym to only overland flow of the water? Answer is no. And to understand it, let us take this diagram. Splash erosion, notice it here. Falling raindrop is causing erosion on the comparatively gently sloping uplying area. Splash erosion is by raindrop. Can we notice sheet erosion on this slope? What is sheet erosion? Sheet erosion is top layer being removed by flash flood water. And mind it, flash flood is considered to be sudden torrential rain largely experienced in deserts. And then as I proceed down with my diagram, I am noticing these rills or gully erosion. I am just highlighting it so that it becomes easier for you to notice. Rill or gully erosion is basically by small rivers which we can call streamlets. And that leads to, and right here we have it, full-fledged channel. This is last but not the least, stream or river erosion. So when you are taking the reference of universal agent of gradation, you actually talk about river. But when I take the reference of fluvial action, I am not just taking into account river, I am taking the splash erosion, sheet erosion, rill or gully erosion. Overland flow and fluvial action correlates with each one of them. Let us quickly take NCERT and one more diagram to further understand. Are we noticing the rill erosion here? And this will be my, noticing? These are gullies. And if I continue downstream, then I can call it stream erosion. So stream erosion can be, not necessarily always be, combination of different. I say stream erosion is combination of different gully erosion. I need to safely understand this point that several streamlets, small stream, combines to make a stream. So rill erosion or gully erosion can be taken up as examples of overland flow. And now I take you to NCERT. Running water. In humid regions which receives heavy rainfall, running water is considered as most important of geomorphic agent. There are two components of running water. One is overland flow or general land surface as sheet. We have talked about sheet erosion. I am numbering it as 1. And the another, I am numbering it as 2, is linear flow as streams and rivers in the valley. Most of the erosional landforms made by running water are associated with vigorous and youthful stream flowing along the gradient. Now when I talk about overland flow, I have got two types that we have learned with the previous image. Which are the two types of overland flow? One is the sheet flow and one is the gully streamlet or stream flow that is being combined in NCERT. Beyond that, if I ask you to take reference of NCERT content right here, the overland flow causes sheet erosion. Depending upon the irregularities of land surface, the overland flow may concentrate onto the narrow to wide path. And this is what we need to understand as stream action and developed valleys. Now, running water as an active agent of gradation involves what mechanism of functioning? Let us try to note that one by one. So, ideally, any stream will have three courses: upper course, middle course and lower course. And when I say stream has got three courses, what exactly I want to say? It is referred as long profile of stream, which has got near source. So when I slightly enlarge this diagram and ask us to understand the point that we are trying to make, I as a river mark my beginning from the source area. Source can be glacier, source can be lake, source can be any. From where I am moving down slope, and when I am moving down slope, I am actually moving till my mouth. What is mouth of the river? Mouth of the river is the location where river terminates its existence. It can be sea, lake, ocean, any point. In upper course, if we are talking about the courses of the river, so in upper course, river is essentially engaged in valley deepening, near source, course number 1. And in course number 2, river is actively engaged in valley widening, because notice that the gradient is on decrease. And once I reach my near mouth, I am actively engaged in deposition. Why? Because the gradient is continuously decreasing from the upper course to the lower course. In long profile, river in its three courses thus is engaged in deepening, widening and deposition. Now, if I as an active agent of gradation is engaged in these threefold tasks, what exactly is the action that I will be performing? Basically, to facilitate deepening or widening and deposition, these all are collectively called stream processes. Let us try to understand each one of them one by one. River as active agent of erosion is engaged in abrasion. Basically, the process of abrasion is valley development. It can be valley deepening or it can be valley widening. Second is attrition. Attrition is mutual wear tear. When the pebbles are being transported, they tend to collide with each other, and that results into mutual wear tear, which is called attritional effect. Solution, we have talked about it several times in our understanding of exogenetic forces. What is solution? Rocks are made up of minerals, and rocks are made up of minerals, and minerals are soluble also. So once coming into the effect of river, it can result into corrosion. So that can be detachment because it is getting dissolved. And can we notice in this diagram the hydraulic impact in cracks and joint? Hydraulic impact is largely referred as pressure exerted and pressure released, the continuous process that leads to it. So river as an active agent of erosion is engaged in 4 types of tasks. Which are they? These tasks are called abrasion, attrition, solution and hydraulic action. With all these processes, I am continuously generating broken rock material. Please recall the term called rock debris. And this rock debris is transported by river. When we talk about transportation of river, there are again certain mechanisms that we have to take into consideration. Which are they? Transportation involves suspension, has to be of finer textured material. It will be solution, which we have already talked about. Some minerals forming rocks are soluble in water. And then we have got, and I am writing it here in bold, the bed load. Bed load by default will be coarser material, is either transported by the mechanism of traction. See, this traction is where big size pebbles simply roll down. Are we noticing these pebbles? These are simply rolling down in the movement of river. They are rolling down on the bed of the river. River bed is mentioned here. And we also have saltation. And what is saltation? Comparatively smaller size pebbles. Downstream, they are thrown up and then they settle down. Saltation is long leap movement. Quickly remind, river as an active agent of gradation erodes by 4 mechanisms. Which are they? Abrasion, attrition, hydraulic action and solution. And what is the way river transports? River transports by 4 different mechanisms, namely suspension, solution, traction, saltation. And which are the bed load movement? It is traction and saltation, because suspension by default will be of finer textured material. When we talk about transportation, we also take into reference 2 important terms. Transportation capacity of the stream is what is the quantity that stream can transport, and competence is what is the size of the particle that river can transport, and both of them are dependent on the velocity of the stream. Higher the velocity, higher will be capacity and competence. I hope it sounds logical. So when I am talking about river as an active agent of transportation, what are the important aspects that I have to keep in mind? I have to keep in mind the capacity and competence comparison and the mechanism by which stream transports. So what are the mechanisms by which stream transports? Suspension, solution, traction and saltation. Saltation is long leap movements of the bedrock. The stream process, apart from including erosion, transportation, also involves deposition. And in order to integrate them, we have selected this curve, and this curve is called Strom curve. Notice carefully that on horizontal axis we have been given the particles, size of the particles. So I have got clay, silt, sand, gravel, pebble, cobble and boulders. So I am increasing the size of the particles here, and I am increasing the flow velocity on vertical axis. So Strom curves gives us the comparison between transportation, erosion and deposition capacity of the stream. So can you have the relation that has been applied? As and how I increase the velocity, As in how I increase the velocity, I'll be increasing the particles eroded. However, the eroded particles is also being correlated with the size of the particles. So, can we notice this blue patch which is showing the particles eroded? And what is the bottom curve? The curve which I am highlighting with red color now, erosion velocity curve. It is significantly high when the texture of the material is low, and it becomes decreased in spite of similar velocity more or less when the particle size is bigger. And can we notice the settling velocity curve? Settling velocity curve is significantly increasing with increase in the size of the particle. And if I take these two curves which are called erosional velocity and settling velocity curve, I can easily take the transportation networking in between. So, what is Joule-Strom curve actually applied with? It is applied with erosion velocity curve and settling or depositional velocity curve. What exactly these curves are showing? That deposition or particles deposited will not just be dependent on velocity. Higher the velocity, lesser will be the deposition, provided particles are smaller in size. So, river erosion or river transportation capacity essentially is regulated by size of the particles and the flow velocity of the stream. They combine to make the validity of river action. So, quickly repeating it, river agent of erosion, what is the erosional agents or characteristics? Erosional characteristics includes abrasion, attrition, solution and hydraulic action. River as agent of transportation, saltation, traction, suspension, solution. Transportation is never complete without competence and capacity. And river as an active agent of deposition. Deposition is lower the velocity, larger the size of particles, higher will be settling. Which curve? Joule-Strom curve. Now, if I take the characteristics of erosional landforms as mentioned in NCERT, the first reads valley. Now, valleys starts as small and narrow rills, and rills are eventually enlarged, and many types of valleys like V-shaped, gorgeous, canyon can be recognized. Now, you need to understand, if I just make a very simple set of diagram here, V-shaped valley is distinguished from I-shaped valley primarily in terms of its shape. And how I'll be developing a V-shaped valley? I'll be developing a V-shaped valley if my bank cutting is stronger than my bed cutting. So, lateral erosion is higher than vertical abrasion. So this is how I'll be developing a V-shaped valley, and compared to it, how will I develop the I-shaped valley or a gorge and a canyon when my lateral and vertical abrasion is common. So our gorge is being given in NCERT. A gorge is a deep valley with very steep to straight side. A canyon, in comparison, is characterized by steep step-like side slope. So what exactly is the difference between the canyon and the gorge? I want you to read it here. V-shaped valley. A gorge is a deep valley with very steep or straight sides, and a canyon is characterized with steep step-like sides. So if I have to make the difference, I'll say this will be my canyon, more like river terraces. And then it also says a gorge is almost equal in its width at top and bottom. In contrast, canyon is wider at the top than its bottom. So if I have to make a general comparison between the two, I'll say this will be my example of canyon, and that I-shaped valley will be my example of gorge. So how many types of river valleys we can actually take into consideration? The river valleys that we can take into consideration are 3. Erosional feature developed by river called valley are V-shaped valley, I-shaped valley. NCERT very clearly defines it as gorges, and canyon. And what is the fundamental difference between gorge and canyon? Gorge, I-shaped valley. Canyon is more or less broader at the top, narrower at the bottom, and have got steps related to it. So I don't see those steps when it comes to gorge. So 3 types of valleys. And what is the process developing it? Vertical, use the term abrasion. What is abrasion? Process of creating valleys. Second feature mentioned in NCERT is potholes and plunge pools. Now potholes and plunge pools are best defined as this. Now carefully understand, supposedly this is my water level from where the river is falling with great force, whatsoever is the reason. Now we are taking reason to be kept in reserve, and I have just created out a quick diagram for us to understand. A stream was flowing here, and stream now has started falling down here. So falling force of water by default will create this erosional hollow. If I just enlarge it, this is my waterfall, and falling water will create this pool, because there will be additional erosion. So potholes and plunge pools are largely correlated to each other, but they are not necessarily the same. But when we talk about waterfall, we always relate it to plunge pool. They are also examples of vertical abrasional feature. Let us see them with this diagram. Are we noticing it? Waterfall, this is my head rock, which originally was extensive till here. Continuous falling force of water. There can be the retreat of waterfall. How? This will be broken and will fall down. And right here the fallen rock, and this is my plunge pool. Overhang. Overhang is that non-eroded water pebble which can eventually be falling down. So this is my waterfall with plunge pool. Retreat is headward. Why? The hard rock topples over. Water have started falling from significantly greater height. Falling force of water tends to create plunge pool. And these are the pebbles which are deposited here, which will be transported by stream eventually. The undercutting that is being done by the falling force of the water, we can easily see these undercutting. This is the arrow which I want you to notice. So plunge pool basically is an example of erosional feature developed by waterfall. And why the retreat is headward? Because by default earlier the wall was still here, now it has got retreated till here, so it will eventually be retreated for the leveling to be done. And how exactly we distinguish it from? If I believe that this is my slope on which an active channel is moving and it is experiencing differential resistant rocks, stage 1. And if I have to label it, I am labeling it as this is my hard rock and this is my soft rock. What is likely to happen in due course of time? And if you try to give it a 3-dimensional look, it will give you the understanding of what can be called as potholes. These can be the potholes. So do remember, in natural scenario, it's very difficult for us to demarcate that a rapid cannot grow to become a waterfall, or a waterfall was not originally a rapid. But theoretically, we can have a distinction. So what exactly will be the pothole? If I just try to make it here, that if this hard rock strata continues to be extended like this, what will happen? That river will be eroding this block first. So it will be scooping out the pebbles from here, right? And as it will be scooping out the pebbles from here, what will happen in due course of time? In due course of time, there will be the development of several depressions right here. And that can be considered as potholes. And the feature that is developed is rapids cascade. Going back to NCERT, over the rocky beds of hill stream, more or less circular depressions called potholes are formed. And when we take the series of such depressions, joins, the valley gets deepened. At the foot of the waterfall, there is large potholes that we have learned are called plunge pools. So you actually need to relate them. It's something that cannot be an absolute divide. So river as an active agent of erosion has developed valleys, has developed potholes and plunge pools. River as an active agent of erosion also develops, number 3, incised and entrenched meander, incised meander, ingrown meander, an entrenched meander, a rejuvenated meander. Let us take their understanding with comparatively simpler diagram. Meanders are sluggish flow. So it is always on gentle slope. Valley is marking its changeover like this. Are we noticing the meandering course of a stream? When we talk about meander, we are actually moving sluggishly like this. And this sluggish flow incorporate one depositional bank, this is my depositional bank, and 2 erosional bank, this is my erosional bank. And it is basically with this erosion and deposition that we can have the distinction between meandering stream erodes deposits. Are we noticing this is always erosional bank? So here there will be pool development. Here there is pool development, but there is point bar deposit here, right? Point bar deposit here. So this is depositional bank, this is depositional bank, and this is depositional bank, this is erosional bank. So meandering is sluggish flow of the stream. This sluggish flow tends to develop depositional and erosional bank, and this depositional and erosional bank can be referred as, and I am referring erosional bank first. What will be erosional bank called? Erosional bank correlates with thalweg, river cliff, and depositional bank is point bar deposit. Meandering stream, depositional bank, thalweg, erosional bank, and this erosional bank basically facilitates deposition. This subsurface flow is called helical flow, which makes the eroded material from this bank transported and deposited on the opposite bank. The helical flow facilitates development of deposits, bar deposits. And this is the direction of the channel migration, because I am meandering, I am migrating on this end. Ingrown meanders. See more expressive diagram. Meandering stream, riffles. Meandering stream, erosion. Erosion does pool. This is erosional bank. Noticing? These are point bar deposit which keeps on increasing. This is again pool, like pool here. Pool, point bar deposit, pool. Whenever there will be lesser water volume, so this is my meandering stream, so my stream is making its channel flow towards that direction, right? And if you try to see this flow direction in the general sequence, what you can add to it is, when water volume increases, a river tends to take shorter route. Developing Oxbow Lake. So if I have to believe this as my floodplain, what is the way I will be labeling it? Carefully see this. These will be called bluffs, bhangar in India. These are called floodplain, plains that are developed during flood, khadar. And this will be my Oxbow Lake. Reason? when there is a larger water volume, river will take a shorter course and by default will leave the loop behind. If the water reduces, then it possibly will take this loop again. And don't miss to see, these all are point bar deposits here. Yes. So meandering, which type of meander? Ingrown meander. What is meandering? Meandering is the sluggish flow of an active channel. But sometimes with an active channel, we do come across a term that is called entrenched meander. And what is entrenched meander? Entrenched meander is vertical abrasion in meandering stream. So what exactly is entrenched meander? Can we see this image if I slightly zoom it more? The active migrating and meandering stream have suddenly started cutting its valley. Noticing it? Deep valley here. Which type of stream it is? It is rejuvenated valley that has started developing vertical abrasion. And the best example of it, I have got the image here. Can we notice the meandering stream in this image? And don't miss to see this valley deepening that it has actually created. Which type of meander this is? Don't miss to see the depth that is involved here. Grand Canyon of River Colorado. Excellent example of entrenched meander. So what is entrenched meander? Entrenched meander is when river starts valley deepening in spite of meandering. And it is largely related to rejuvenation, and rejuvenation is that river has reattained youth because of any endogenetic forces that has led to its vertical upliftment. It's all here, right here. I hope you are visualizing it. So which type of meandering it is? The meandering here is entrenched meander. NCERT now, it very clearly gives us the reference of, in streams that flows rapidly over steep gradient, erosion is concentrated. Also in case of steep gradient, lateral erosion on the side of the valley is not much when compared to stream flowing in the low and the gentle slope. Now because of the lateral erosion, streams flowing over gentler slope develop sinus or meander courses. That meandering course we have learned, this is called ingrown meander. But very steep and wide meanders can also be found in hard rocks. Such meanders are called incised or entrenched meander. The meander loops developed over original gentle slope and loops get entrenched into rocks normally due to erosion or slow continued upliftment of land. This is the point that I was trying to give you. That under what conditions do we develop entrenched meander? Re-upliftment. This is important. And excellent diagram. Please recall the difference that we attempted few minutes back between gorges and canyons. Are you noticing that we have got absolute mirror image of steps, paired terraces, and it is different, unpaired terraces. So what exactly are river terraces? River terraces are the surfaces marking old floor or valley, floodplain valleys. It actually incorporates erosional variation as well as rejuvenated variation. So I can have paired terraces if it is, say, a erosional feature that has been referred as canyons. It can also be the floodplain where we are having rejuvenated downcutting. Like we can talk about it as valley in valley topography. There are number of such terraces at different heights indicating former riverbed level, and river terraces may occur in the same elevation on the either side. So, if it is same on the either side, it is paired. If it is not same, it can be unpaired. And if we read the development as given in our NCERT, the unpaired terraces are typical in the area of slow uplift of land or where the water column changes are not uniform. The terraces may result due to receding water after peak flow, change in hydrological regime, and tectonic upliftment of land with sea level changes. All these goes with rejuvenation. River terraces. Can we easily say that these are paired terraces that we are noticing? Yes, we are. And we have already seen this image in NCERT. Paired terraces can be the outcome of tectonic, sea level change, or water volume change. Initial stream profile: gentle, steep, gentle. Young stage of erosion. Continuous removal by erosion. So, this slope has changed, and continuous filling up by deposition. Mature stage. All variation. This was original slope. All variations leveled. Here it was eroded, here it was deposited. Graded stream profile develops peneplain. Young, mature, and old stages removes all variations, creating leveled feature, peneplain, that can have some monad knocks. In the early stages, down cutting dominates, during which irregularities such as waterfalls and cascades will be removed. In the middle stages, streams cut their bed slower and lateral erosion valley side becomes severe. Gradually, the valley sides are reduced to lower and lower slope. The divides between the drainage basins are likewise lowered until they are almost completely flattened, leaving finally, number 3, leaving finally a lowland of faint relief with some low resistant remnant called monadnocks. This type of plain forming as the outcome of stream erosion is called peneplain. Actually, these 3 stages can be called cycle of erosion. And see them one more time. Stage 1, 2, 3. Take this part of your NCERT for your revision. It will be now easier for you to take all the features which are there. 2 parts. Number 1, which are the erosional features and what is the stages of erosion that we have talked about. Happy learning to all of you. All the very best.